Hello everyone, welcome to my U programming club. Today we will be solving another daily Leetcode problem, and the problem's name is find first palindromic string in array. So the problem statement goes like this. Given an array of string words, you have to return the first palindromic substring that can be found in that array. If there is no palindromic string, then you should be returning an empty string. String, for those of you who do not know what a palindrome is, a palindrome is a string that reads same forward and backwards. For example, if race car is read forward, it will be RACECAR, and if it is read backward, then it is RACECAR. Okay, so it is reading same forward and backward, that's why it is a palindrome. Similarly, this is also a palindrome, ADA forward and ADA backward, so it is also a palindrome. So it was appearing first, okay, if we are traversing from left to right, so that's why we returned this. Okay, so that is how we'll be approaching this problem. We'll be just traversing it once and we'll be seeing whether the current string that we are on is a palindrome or not. If it is a palindrome, then we will be returning that string. Okay, so let's see the constraints before thinking about a solution. So the constraints here are that length of the words array is of order 100 and words dot length is of order 100 also. Okay, each entry in the words array is of order 100 length, and it is mentioned that each entry in the words array consists of only lower English letters. Okay, so let's see how we will be solving this particular problem. Suppose this is the array given to you. You are traversing from left to right, okay, and you are checking each string. That strings are s1, s2, s3, each string one by one. So you will check for s1 whether this is a palindrome or not. So now problem boils down to finding out whether the given string is a palindrome or not in most efficient way that is possible. So what we can do is, let's say take the we take the example of race car. Okay, so let's take 2 pointers. We'll be using a 2 pointer approach. This will be your left pointer and this will be your right pointer. Okay, we'll be comparing every word that is pointed by these pointers, and if at any instance those words are not equal, then we'll say that okay, this is not a palindrome. Else, if every word pointed out by these 2 pointers are equal, then I will say that okay, it is a palindrome. So what we will be doing is we will be moving these pointers in this fashion simultaneously. So first of all, R and R will be compared. Okay, they are equal, we are fine. Then A and A will be compared. Okay, they are fine. Okay, left and right pointers will be moving. Then C and C will be compared. Okay, they are also equal. And then left and right pointers will be both pointing to E. So this one is also equal, we are fine. Then we will terminate our search whenever left pointer becomes greater than the right pointer. This will be your right pointer and this will be your left pointer once you get past this E. Okay, and you will terminate your search here. So the search will continue till left and right pointers are less than or equal to. Okay, so this condition solved, then you will keep searching and you will be moving both of the pointers simultaneously. Okay, right will move in this direction and left will move in this direction. So that's how we'll be approaching to find out whether a string is a palindrome or not. Now let's implement this approach. And if you may ask, what will the time complexity? Suppose string length is the maximum string length that can be possible in this particular array, and let's say length of this particular array is n, then we can say that it overall time complexity will be n into string length. Okay, and you may see that both of these are of order 100, so you can safely say that it will be 10 raised to power 4. Okay, so 10 raised to power 4 number of operations will be required by your by this approach. Okay, and it is very much lesser than the operation limit of 10 raised to power 8 operations. Okay, this is our operation limit. If the number of operations required by a program to solve a particular problem are lesser than this limit, then your solution will be getting accepted. Okay, so let's see the implementation. Okay, since it is implementation wise not that heavy, so I'll be implementing it in the video itself. So let's begin. If let's say there is no string that is palindrome, then we are told to return empty string. Okay, once that is out of the way, we'll be searching for the first string that can be there, which will be a palindrome. Okay, we are using a for each loop. And now we'll be checking if this word is a palindrome. Okay, this is a function that will return us whether that word that we are currently checking for is a palindrome or not, and if it is so, then we'll be returning this word. Okay, now we have just left out with only one task, which is implementing this is palindrome function. Okay, we will do the same that we discussed. Okay, two pointer approach it will be. Okay, and then while left is less than equal to right, we'll see that if word pointed out by left is not equal to word pointed out by right, then in that case this is not a palindrome and we'll be returning false. Otherwise, we are fine. So we can make the increments, making left to go towards right and right to go towards left here itself. Okay, these are the post increments, so they won't affect the comparison. And then if everything looks fine, then we'll be returning true. Okay, so let's check for the sample test cases. As you can see, it's getting accepted for the sample test cases. Let's submit for the final evaluation. or let's say, you know, okay, let's submit anyhow. Okay, as you can see, it's getting accepted. And space complexity wise, we will not be using any extra space. So that is how we will be solving this particular problem. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.